What are we doing? What are we doing here? We are going to find the derivative implicitly via this equation, and then we will find out when the tangent line is horizontal or vertical. So horizontal will mean that y prime is 0. And then vertical will mean that y prime does not exist. You may find it useful to think of this as y prime equals plus or minus infinity. Okay, so we take a derivative of both sides of this equation. What do we get? We get 3y squared y prime minus a product rule. So 1y plus xy prime equals the derivative of -6, which is 0. Okay, as usual, we will keep our y prime terms over here, everything else over here. So we get 3y squared y prime minus xy prime is equal to y. This guy went over here. It had a minus, became a plus. Okay, factor out y prime. And solve for y prime. La la, ooh la la, ooh la la. Et voila. Okay, so as I said, horizontal means y prime is 0. Vertical means y prime does not exist. Useful to think of that as plus or minus infinity. Okay, y prime is equal to 0. What does that do for us? How can this fraction here be 0? Well, for a fraction to be 0, the numerator must be 0. So y must be 0. Y prime does not exist. That's when the denominator here, this guy, is 0. Okay, division by 0 gives me the dne. So x is equal to 3y squared. So what does that tell me? Well, this isn't super helpful, but I'm going to combine it with that original equation there, and I get y cubed minus x, which is 3y squared, times y. Okay, so again, I took this and use it there. Okay, basically plugging this in here. And what do I get? Y cubed minus 3y cubed is -6, giving me minus 2y cubed is -6, so y cubed is 3. So y is the third root of 3. All right, so what does that get us? Well, we're looking for points where y prime does not exist. So let's find the corresponding x value. Okay, we got the y value. The corresponding x value is given by this guy up here. So we get x is going to be 3 times third root of y all squared. What can you do there? Not much. 3 times y to the 2 over 3. Okay, you'll remember that this thing here is y to the 1/3. All right. What have I done here? A big mistake. X is 3y squared. Oops, x is 3y squared. And I meant to plug this in here, but instead of putting the 3, I put a y here. So let me just correct that. This should be a 3. And this should be a 3 dot 3 to the 2/3. Sorry about that. Okay, so there's my x value, there's my y value. Okay, that's the point at which I have a vertical tangent line. And then for the horizontal tangent line, I have y is 0. And what happens there? Well, come back to my equation here and plug y equals 0 in, and I get 0 is equal to minus 6. Nope. So I conclude that this is never horizontal. And it's vertical at the point this complicated point here. What is it? I said y was third root of 3, and x was this thing down here, 3 dot 3 to the 2/3. That is ugly as sin. Okay, let's move on to an exercise. I want you to pause, copy, and try this one out. Pause, copy, try. Okay, here we go. Solution time. Take a derivative of both sides. Get it 2x plus 2y. Y prime is 0. And I get to solve for y prime, I get minus 2x over 2y. So y prime is minus x over y. So I'm asked to find when is the tangent line, when does it have a slope of a half? So I want this to equal a half. So that can be written as y is equal to minus 2x. And I'll take that dude and plug it in to my original. Equals 20, and what am I getting here? I'm getting 1x squared, and then plus 4x squared is 5x squared is 20. So x would be plus or minus 2. And then the y is given by this equation. So the sign changes, so I get a minus here. So I get minus plus 4. Okay, another way to interpret this is 2 points. I got plus 2 is going with minus 4. And minus 2 is going with plus 4.